Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is F-1, Introduction to Functions. We'll start by going over some vocabulary terms that you need to know for this. Relation, any set of ordered pairs. Function, function is a set of ordered pairs, x, y, such that for each value of x, there is only one value for y. Input, input is the x value or independent variable. Output, output is the y value or dependent variable. Domain, the domain is the set of all first coordinates, the input values, or also known as the x values. Range, range is the set of all second coordinates, the output values, or also known as the y values. We'll start by taking a look at question number 1. Tell whether each relation represents a function. Explain. So we have this set of coordinates and we need to determine if it is a function. Remember, a function is that for every x value you have, the y value that corresponds to it is unique or different for each one. So we have a 2 and an 8, 2 for x, 8 for y. Here we have a 5 for x and a 6 for y. Here we have a 2 for x and 8 for y, a 6 for x and a 9 for y. So I notice immediately that my x's for the 2's, in order for this to be a function, my y's would have to be the same exact numbers, and they are. So the 2a and the 2a indicate that this is in fact a function. Now let me look at the other two pieces of this. I have a 5, 6 and a 6, 9. Well, my x's are different numbers and my y's are different numbers. So that supports the idea that this whole set is a function. And so I can classify this as a function because every x value has exactly one y value. Now let's take a look at 1b. I have 2, 8, 2, 6, 2, 7, and 2, 9. Well, immediately I notice that my x's are the same in every one of these coordinates, but my y's are different. So that indicates that this can't be a function because the x value of 2 has 4 different y values. Okay, let's move on to question number 3. Determine whether each graph represents a function, then explain why it does or does not represent a function. And the key here is to remember the vertical line test. And the vertical line test is that this vertical line, when it passes through any part of the graph that you have, it can only touch in one spot. So let's pull it over here to A. If I start it over here and slide it along, it only touches in one unique spot. So that indicates that this is in fact a function. Now if I move it through B, immediately I start to notice that I'm hitting two spots at once as I slide along this. And because of that, this is not a function. It fails the vertical line test. And then if I come to C, C sits right on the vertical line. And so clearly all the spots are touching the vertical line at the same time. And so this is also not a function. It fails the vertical line test. And let's take a look at question number 6. It says, in the function y equals 2/3 x plus 10, the output is 58. What is the input? Well, remember the output is the y value. So as I rewrite this, I can substitute 58 for y, and that still leaves me with 2/3 times x plus 10. I can then remove 10 on each side, which is going to give me 48 equals 2/3 x. Now, as you look at this, you may be inclined to think initially, well, let's see, I have to divide by 2/3 to remove it, and then do the same thing over here. But keep in mind, this is a fraction, and if you divide by a fraction, if you're dividing with two fractions, you need to actually get the reciprocal of the second fraction and multiply. So what that's going to look like is I'm going to be multiplying by the reciprocal of 2/3. So I'm going to multiply by 3/2 on this side, and this is going to 2 times 3 is 6, 3 times 2 is 6. That's actually going to work out to be 1. So it isolates x by itself. And over here, I'm going to multiply 3/2 by 48. And I did that over here. So I have 3/2 times 48. These guys cross out. So my 2 becomes a 1, my 48 becomes a 24, and 3 times 24 is 72. And so the input is 72. Please use the work that was done for you tonight to help you to solve the additional problems that are on your homework. And remember, the key to success in math is not only working hard, but working smart.